Last thing we're going to cover here is this idea of the best fitting line, because this one is going to take a little bit of work, but it's just kind of one of those teachable moments. What SPSS does is it tries to create, if you look at that visual, kind of a best fitting line that kind of goes through all of these points. And so the idea is, what we're going to do is it creates its own equation, and I actually wrote it down for you. And if you look at that equation, can you see that under the best fitting line, that B thing? Do you see where I put the Y hat? So if you want to make the letter Y and just put a little hat on it, you can do a better hat than I can. Yeah, the book has it, Y hat. So the Y hat, and then look what I did next, 6.25x. Where did I get that 6.25 from? It looks like it's right under variable 001, right? Do you see the 6.25 there? Kind of grab that, and then I did, on my equation, minus 185. I took that 184.7, and I just rounded to 185. This is called the best fitting line equation. And what I'm going to do here, and I know you might have a lot of questions, but I'm going to try to kind of get to the point here because it's not worth 2 hours here. It's worth 10 minutes more. So let's do an example of this. Look what I did under that. I have these BMIs. So when the BMI was 30, this equation is called the best fitting line equation. So what we do with this is we actually, I think I did this right, yes. Let's put the number 30 into this equation. You might consider BMI as an X variable. That might be your X. So let's put the 30 into our equation. And if you have a calculator, Beverly, do you have a calculator there?
Yes.
So if you have a calculator, put the 30 into the math there. And Emily and Drew, if you have one. Emily, I can do it for you here if you like, or you can use mine. Yeah, put the 30 in there.
I have a calculator.
Okay, you can take yours. If you put the 30 in there, it would be what? 30 times 6.25 equals what?
187.5.
And then subtract what? What? Subtract the 185. What do you get when you subtract that?
2.5.
2.5. So what did your best fitting line predict for that? It actually predicted 187. No, I'm wrong. What did it actually? You put the 30 in there.
You get 2.5.
Oh, I'm sorry about that. I screwed it up. The predicted value is 2.5. So this is the best fitting line equation prediction for 2.5. What was the real result here?
So 30 times
Not quite.
0.25.
Yeah, well, it's 30 times 6.25 minus 185. It's 30 times 6.25 minus 185. That number, the predicted number of snoring episodes, is actually 2.5. What were the actual number of snoring episodes when the BMI was 30?
Oops.
Emily, you'll need to pay attention here. Go ahead. Let me ask the question again. What was, we said the predicted number when the BMI was 30 should be 2.5. The actual number, Drew, was what?
10.
It was 10. Do we want the actual number from the data to be close to the predicted number? Yes. What is the error there? What is the actual error?
7.5.
It's 7.5. So let's go into the error column and just point 7.5 in the error column. And in your next one, what is it actually asking me to do? Beverly, what is the last column asking me to do with that error?
To square it.
Square it. So why don't you go ahead?
56.25.
Yeah, let's put that there. 56.25. So that was
How did you get 2.5?
that was by putting the 30 for the BMI into the best fitting line equation, and it predicted 30 times 6.25 is 187.5 minus 185. The predicted was 2.5. Let's try the next one. The next BMI, Emily, is what? What's the next BMI? Tell me. What's the next BMI?
The next BMI is 32.
Yeah, let's put 32 in there. 32, you can just write it out in your notes. 32 times 6.25 minus 185. Somebody do the math on that?
15.
You got 15?
Did I do that right?
Beverly, did you get 15 as well?
Yes.
15. It is indeed 15, so the predicted snoring episodes was 15. Why would I smile about that?
The actual 0 error.
Yeah, there was 0 error. The predicted value was the actual value. So the error is 0. And what's 0 squared?
0.
0. So that's 2. We're going to do this for all 5 of them. Let's try 35 next. When your BMI was 35, what's your predicted y hat? 35 times 6.25 minus 185.
I got 33.75 for that one.
33.75. Beverly, what did you get?
33.75.
Go ahead and write it in there. 33.75. And if you get the error, what was the actual value?
25.
So it's like 8.25. So the error is 8.25. The error is 8.25, and 8.25 squared. Right, 8.25. You can keep it going. What's 8.25 squared?
I think it's 8.75.
Oh, 8.75, sorry. 8.75 squared.
76.56.
76.56.
Okay, how do you get 8.75?
Your predicted value was 33.75, but the actual value was 25.
So you subtract.
Yeah, that's error. This is what you hope you would get, but you got this, so that's error. Subtraction.
Okay.
Let's do the next one, 38. When the BMI was 38, what would be the predicted value? What was the predicted value? Drew?
I got 52.5.
52.5. Beverly, did you get 52.5?
Yes.
Uh-huh. And so what's the error there? Miss Emily, what's the error for that one? 52 minus 40. Come on, Em.
Oh.
What's
Minus
52?
40. Oh, I was looking at the 80.
What's 52 minus 40?
It would be 12.5.
12.5. Exactly. And 12.5 squared?
156.25.
Say again?
156.25.
156.25. And thankfully we're on the last one here. Had to do a little bit of this. When 40 is the number, what'd you guys get? Beverly, what'd you get when it was 40?
65.
65 is the predicted. Emily, what would be the error associated with 65? 15. And 15 squared is 225. And if you actually took that chart I had, what we're actually doing here is seeing how the predicted is different than the actual. So that graph, you could actually draw kind of a straight line, and you'd hope the predicted values are close to the actual ones. Don't worry about the details though. So the idea is, what I'd like you to do as your last task, and Emily, you can use my calculator or yours. I'd like you to add up all the error squareds. Add up the 5 values for the error squareds.
can leave it there.
And I'd like you, once you add all that up, to look at that ANOVA summary table and tell me if anything looks copacetic, looks okay. Add up all of those values, the 56.25, the 76, the 156, and the 225. Does anything look similar to anything in the ANOVA summary table that we did before?
Just the error? Or,
Just the error squared.
Oh.
The error squared.
Yeah,
Beverly, did you get anything that looked comparable there?
It looks really close to the summer squared for the residual row.
That is exactly correct. Very importantly, Drew, did you get something like that as well?
Yep.
So what did you get for your sum of the errors squared when you added them up?
513.06.
Say again?
513.06.
Yeah, 513.06. Is that what you got, Beverly?
I got 514.06, but I could have added.
That's
Yeah,
what I
like
got.
513, 514. So this is that residual. Guess what that residual is? It's error. That is error. So that is the bad stuff. And in this case, the bad stuff wasn't really that bad because the line, the predictive line, is actually pretty good. It's a pretty good predictive line. So this gives you the best fitting line. And we actually got the error. What you really want here, and maybe the take-home point, and actually Drew has a really nice graph there. What you actually want is you want the predicted spot to be very close to the actual spot. That would mean the best fitting line is a good predictive equation. So we've actually covered here, I think in a pretty good way, the idea of regression here. So I'm going to stop this one.